Hello everyone, welcome to the next video lecture. So this video is related to block diagram reduction techniques. Block diagram reduction technique. That means if you have a block diagram, as I said in some videos before, there is a block diagram which is related to the alpha beta to DQ, DQ to alpha beta, and after that ABC to D to alpha beta, and after that some conversation plus or minus will be there, a load will be there, reference will be there. So that is completely which is having a multiple blocks will be there. So if that a diagram or a representation or a control logic which is having multiple blocks are involved into it, then we need to reduce into a simple one line block diagram or a two line block diagram. So regarding that itself, we will use some type of techniques or call it as a block diagram reduction techniques. So in this video, we are going to cover the topics which are called as a block diagram reduction in series. If they are in an entire series, multiple series blocks are connected, then how it will happen? If there's entire parallel happen, how it happen? And if there is a combination, then what will happen? So this way, what are all the type of things will be there, that how it will be calculated, that how it will be reduced, that we will discuss in this video. So block diagram reduction technique. So what of this diagrammatic representation? So I'm just saying it as a, if consider just like it as a 1, 2, 3, 4, 5, 6, 7, 8, 9, nearly 15 to 20 blocks are there. If that 15 to 20 blocks, let's consider like that, this 15 to 20 blocks are related to the 15 to 20 elements in a network, then how can we design this? Every element will have some equations will be there. So every equation will have some things will come. So this every equation will reflect somewhere, every equation, every element will reflect in the equation, that then the transfer function or the whatever the equation, ultimate equation, that will be very much very big and very complexity. So to reduce that one itself, we will use this block diagram. So block diagram is a visual representation. Okay, it is a visual representation of a system showing how input signals are transforming into the how output signals are functioning. Each block represents a typically a transfer function. For example, one block may represent, for example, let's take it as a this is a block. I can represent like the AC to DC. That means it's a rectifier. So input AC signal will be there, right? And also output DC will be there. So this may represent one transfer function also will happen. So like that, one every block will have one transfer function representation will be there. So that is what the block diagram will be. Okay, why to reduce block diagram is to reduce a simplifying a complex interconnected system into a single transfer function, and also it will able to analyze the system, how it need to be effectively controlled, how it need to be efficiently done, and analyze the situation, analyze the blocks in every system, each and easily. Okay, what are the common elements in the block diagram? Means we have a certain common elements in the block diagram, common configurable configuration. That is, first one is the series blocks. If the blocks are in series, then how it will be, and the parallel blocks and feedback loops. Feedback loop means, as we already see in the closed loop diagram, how the feedback loop is happened. That type of things will be there. So we'll know how to then how to reduce in the step by step. If you see a simple understanding between the series and parallel. So this is a series circuit. Let's take it as a, if I consider this as a one block and this as another block, or then both are in series. In the same way, if this bulb is one block, if the this bulb is in another block, then both are in parallel. Then how it will happen? This can be represented in, it's an example, just not exactly the block diagram. It's an example. Okay, so two blocks in series, two blocks in parallel. Then how it will be represented in the single block diagram? That is how it will operate. Okay, so there are certain rules are there when you are reducing the block diagram. So rule one for series blocks. Okay, rule one series block, what it means, when, for example, when two blocks are in series, as I already showed you, sorry, when two blocks are in series, as I showed you, two bulbs are in series. Let's take it as a one bulb is related to one block. Okay, then the transfer functions are related to, what I need to do is I need to multiply. For example, let's take it as a and B means, then ultimately final output will be related to AB. Okay, in the same way, for example, G1s and G2s are the two series, then the ultimate final function will be G1s into G2 of S. Okay, that is in the when it is in the series blocks. Okay, when it is in the parallel blocks, then what will happen is both we need to, when the blocks are in parallel, then we need to add or subtract. That add or subtract depend upon the sign of which exactly the block represents. Okay, that depends upon, either it can be plus or minus also can happen. Okay, so next one is the feedback loops. If the feedback loops are there, then automatically the standard transfer function will be in this way. So this h of s will be related to the feedback and g of s will be related to the input. So then automatically important transfer function will be changes to g of s by 1 by 1 plus g of s into h of s, because these both are in parallel. So that's why we are taking into consideration of these things. Okay, so these are the three important rules when you are reducing the block diagrams. And the next one is moving. Another one is moving summing points and pickup points. That means when you are seeing in the orthogonal PLL, and that one, if you are see, there is a one block called it as like this, like plus and minus will be there, and after that some blocks will be there, and after that some another blocks will be there. So we can, if the reduction blocks is there, then we can move the summing block to the either to this side or to the back side also can be able to possible. Okay, so because that doesn't affect much in the thing. So but it may reduce the complexity of the block diagram. So that is how it is saying, to simplify the complex diagram, we can often need to move the summing points or take off points ahead or behind blocks. This doesn't change the system's behavior but makes reduction early easier. Okay, now the system behavior not affects anything, but the only the thing is we can reduce the system block diagrams into simple block diagrams. Okay, thank you.